questions, please feel free to interject at any time. So basically, the obviously building codes may require that a fire endurance rating for an application, specific applications involving metal plate connected wood trusses or trusses, have to have the assembly has to be have a fire endurance rating, and that can be a floor ceiling assembly, that can be a roof ceiling assembly, or for an attic separation. The generic fire rated wood truss assembly would be typically look something like this. Now this happens to show floor truss, or what appears to be floor truss, parallel core truss, and basically is going to include the, in this case we're calling a gypsum board, but it would basically be the protective membrane. In this case it also has, it's attached with to a hat channel, which in turn is attached to the bottom cord of the truss. This particular assembly is showing insulation that is basically being supported on the hat channel. And then you've got the truss itself, the framing member, and then the floor sheathing in this case, or the roof sheathing, the structural sheathing. Again, this is just kind of the general guts of an assembly. Truss protection in fire resistance rated assemblies is covered in the building codes, has been for quite some time, and we're going to be basing everything off of the International Building Code. The IBC states that requirements shall be based on the results of full-scale tests or combinations of tests or approved calculations based on such tests that demonstrate fire resistance, and that's in section 704.5 of the IBC. Actually has some additional information that talks about, for trusses. Before we continue, I'd like to just go over a couple of key definitions from the building code. First of all, what's an approved source? Well, that's defined as an independent person, firm, or corporation approved by the building official who is competent and experienced in the application of engineering principles to materials, methods, or systems analyses. Fire resistance is defined as that property of materials or their assemblies that prevents or retards the passage of excessive heat, hot gases, or flames under conditions of use. And fire resistance rating is defined as the period of time a building element, component, or assembly maintains the ability to confine a fire, continues to perform a given structural function, or both, as determined by the tests or the methods based on tests prescribed in section 703. So in section 703.3 of the IBC, there are 6 different methods that are allowed for determining the fire resistance. Fire resist number 1, first method is fire resistance designs documented in approved sources. Number 2 would be prescriptive designs of fire resistance rated building elements, components, or assemblies as prescribed in section 721 of the IBC. Number 3 would be calculations in accordance with section 722 of the IBC. Number 4 would be engineering analysis based on a comparison of building element, component, or assemblies designs having fire resistance ratings or determined by the test procedures set forth in ASTM E119 or UL 263. Number 5 would be alternate protection methods as allowed by section 104.11 of the IBC. And then finally, and this is new to the 2015 IBC, is fire resistance design certified by an approved agency. So method 1, documented fire resistance designs. Basically these would be the fire rated assemblies that say are listed in UL, Gypsum Association, or others. To qualify as a documented design, testing has to be performed The testing is conducted in accordance with ASTM E119, which is standard methods for fire tests of building construction and materials, or ANSI UL 263, which is the sister standard that with the UL that UL follows. When you're doing a fire test, the tested assemblies may be specified where a rated assembly is required. So in other words, if you test for a 1 hour rated assembly and you pass, then that would be an assembly that can be used in 1 hour rated applications that require 1 hour rated assemblies. The assemblies can generally be applied to both floor and roof applications. Obviously, if the assembly was tested with 2330 seconds wood structural sheathing as the subfloor material, and you want to use that assembly in a roof, that's what you're going to have to use. Now, some documented fire resistance designs. There are several sources. One would be the Gypsum Association and their Fire Resistance Design Manual. And there is an online manual. It's a read-only, but it's obviously really great now with the internet. We can easily search, and most of these documents we can at least look at on the internet without having to buy the full-blown document. Another obviously very popular source would be the Underwriters Laboratories. They actually have a searchable database online. It's their fire resistance directory. And also many of the UL tested designs can also be found in the product literature of the companies whose products are certified to be listed in the various assemblies. There are other sources of documented fire resistance designs, and remember, it's got to be by an approved source. And some of these approved sources would be Warnock-Hersey, Factory Mutual, and PFS Corporation, which is headquartered right here in Madison, to name a few. One of the documents that we've put together here through SBCA is this research report, SRR 1509-01, which basically includes simplified summaries of the fire-rated assemblies using metal plate connected wood trusses. The original document was put together, I want to say about 4 years ago, maybe even longer than that, and I think it was about a 7-page document. The latest and greatest, and what you have here is you can see the cover. Maybe you can't read it very well, but the latest and greatest was updated in September 21st of 2016, so a little over a month ago. And it is now a 35-page document, I believe, and it obviously continues to grow. So this document, you can go to the website and download it. And before I go on, I guess I just kind of want to make sure everybody that's on this call is aware of this. If you go to the SBCA website, and the web address, if you type in sbcindustry.com, that's sbcindustry.com, you go to the home page, there's a black strip across the top, and the very last menu item says Technical. If you basically click on that, that proceeds to a drop-down menu, and you want to go to, from Technical, you go to Publications. That then also opens up a drop-down menu, and from there you go to Research Reports, and that will take you to the Research Reports page, where there are currently 32 reports listed that cover various topics involving trusses, wood trusses. You can scroll down and find report number 1509-01, and if you click on that report, first of all, it opens up a brief summary of what's in the report or what the report is about, and then it gives different options, one of which is you can download the report, which is a PDF. The nice thing about that is when you download it, All of the links in the report are hot, so some of these items that you'll see in this presentation that are underlined and in red in the report, you can actually click on them and it'll take you to the actual document that's being referred to. You can also go to there's another option typically is there's an educational program, which when you click on that will give you two options, one of which is there's a PowerPoint presentation that has been developed that's based on the report, and that is either available as a PowerPoint or you can get the slides in PDF format. For those of you that maybe, and I know there are some truss manufacturers, engineered wood people involved in this call, if you're ever giving presentations, whether it's like a lunch and learn type of presentation at an architect's office or whatever, it's pretty handy. You can actually give presentation regarding the report. And then many times there's some type of an installation guide or design guide option that will take you for some of the reports. It basically is going to give installation instructions and safety information. In this case, this particular report doesn't have that because obviously we're not going to go through the installation and safety of every one of the assemblies that's listed in the report. But then in many times too, for a lot of the reports, there's for the building code officials, there's installer and building code official checklists that are available, so they can basically follow the steps to make sure that if it's a research report that involves some type of an installation, then they're installing it correctly, and then the code official has a checklist that they can, as they're inspecting it, can make sure that things were done properly. Okay, I digress there, apologize, but basically when the thing to know about this report is we're including the simplified summaries of the various assemblies that we're aware of that involve metal plate connected wood trusses. But the users must consult the listed testing agency's documentation or tests for complete listing information. And I say that because I spoke with an architect a couple of weeks ago who said that they were really interested in using one of the assemblies because it didn't require a finished flooring, in this case a gypsum layer on the floor. However, when they went to the UL, it happened to be a UL report, when they went to the actual report, that was not an option. It required a finished flooring. And so, and you probably can't read it very well, but the in red right above this table, and this is on page 7 of the report, it just reiterates what I just talked about, that hey, these are summaries, you still have to go to the report number. Now, the information in this document is basically provided based on, first of all, in the kind of a turquoise or what blue-green strip on the very left-hand side of the table. It lists by the assemblies by, first of all, the endurance rating. So in this case, we start with a 1-hour rated assemblies. The category is the next column in, and in this case, if you can read that, it says floor. So on the first page, this would be 1 hour, no insulation in these assemblies. They were tested without any insulation. Category is floor. Then we show kind of an illustration that shows kind of what the assembly looks like, and then we describe the construction, and that typically includes what the on-center spacing is, the minimum depth of the truss member, the amount of what the membrane protection is, such as 2 layers of 1/2-inch type X gypsum. Minimum sheathing for the very top one is 1930 seconds, and that is based on the Gypsum Association FC 5512 report. So if you want to know what the specifics of each of that particular assembly is, you'd have to go to that report. Now the other thing that, the reason I'm showing the first page of this is, if you look at the top here, it basically provides a key for who the certifying agency is. GA stands for Gypsum Association, NER, National Evaluation Service Report, PFS Corporation, so on and so forth. And then it also kind of defines what some of the symbols are that are included in the illustrations. So it's actually, this document is, I think, pretty handy in terms of, yeah, you could, if you have a UL report or fire resistance directory or a gypsum association document, certainly you've got all that information at your fingertips. This is kind of nice because it does provide all the different assemblies, and it goes from a 1 hour, 1.5 hour, up to a 2 hour, as well as the separation, area separation assemblies, say for up in attic spaces or at if the wall is framed with a gable end frame or a gable end truss, what assemblies are allowed for that, or separation assemblies. Okay, so method 1, documented fire resistance designs. In general, the fire resistance rating is of the listed assemblies applies to the entire assembly. Okay, so it's not, you're not getting a 1 hour rating on the floor truss. It applies to the assembly. And with the tested assemblies, the components are not intended to be interchanged between assemblies. So an assembly that was tested with I-joists would not necessarily apply if you wanted to use metal plate connected trusses and so on and so forth. However, method 4 of the IBC, which allows for engineering analysis and comparison, does allow evaluation by comparison of tested assemblies. That is permitted in the IBC. Now, in order to do that, someone has to, make the case, and then ultimately the building official would have to approve or agree that, yeah, okay, in this case, I think that, we can go ahead and switch out these components or whatever, and we'll still maintain the, be able to get a 1 hour rating. Another couple of things about the documented fire resistance designs is, first of all, the depth and spacing. Depths basically are typically given as minimum. So like you'll see with I-joists, minimum 9.5 inch. So anything deeper, if they want to use a 14-inch deep I-joist, or in this case, like trusses, 12-inch deep, and they want to use a 14, or the truss assembly is going to use a 14-inch deep floor truss instead of the 12 that was originally tested, that's fine, because typically the greater the depth of the assembly, the more plenum space you have, and so the more area you've got to dissipate the heat if a fire is occurring below the ceiling line. And then also the on-center spacing, typically that's listed as maximum. So if the assembly was tested at 24 inches on center, but the actual product is going to be used at 12 inches on center or 16 inches on center, that's fine, the assembly would still apply. Question that comes up quite frequently has to do with insulation. And when you're trying to look at these tested assemblies, some assemblies will allow the addition of insulation if an additional layer of gypsum is installed at the ceiling. For instance, if you're looking at an assembly that meets the 1 hour using 2 layers of 5/8 type X, and you want to use insulation in that assembly, and the assembly that you are interested in using or the building designer is interested in using was not tested with insulation. Like I said, some of the assemblies will allow insulation to be installed, but you have to add an additional layer of gypsum type X, 5/8 type X. The insulation we'll get calls periodically regarding questions, regarding that. Typically, insulation could be removed from an assembly and not really affect the endurance rating. However, adding it becomes a bit trickier, especially if it's being added directly above the protective membrane in the ceiling, because insulation typically helps to trap the heat or impede the heat movement through the, from one side of the insulation to the other, thereby intensifying the heat. And if it's installed right at the ceiling line or above the protective membrane, you could end up with premature failure of that membrane and not meet the fire endurance rating of that assembly. There are ways around that. One would be if the assembly was tested without insulation and with a 12-inch deep truss, and you wanted to include 3 inches of insulation, whether that would be for thermal or sound requirements. I know I've seen where they've gone with, okay, if you go with a 16-inch deep trusses and install a layer of 4 inches of insulation up at the underside of the floor decking, that still allows you with a 12-inch plenum space between the ceiling membrane and where the insulation starts, and so you still have your 12 inches, which would meet the requirements of the original test. But again, that's information that needs to be discussed with the building designer, and then obviously in particular, then the building designer needs to sell that, if you will, to the code official for final approval. And again, the IBC in section 703.3, method 4 and 5 does permit modifications to the assemblies. However, as I just said, this would include modifications involving insulation, but rational design must be provided to the building official for his or her final approval. Method 2, prescriptive designs. In the IBC table 721.1 para 3, there is a whole list of prescriptive designs, and of those there is one that describes a 1-hour prescriptive rated floor and roof assembly that includes wood trusses. And what we've got on this slide is basically just the general requirements of that assembly. So in this case, you're directly applying 2 layers of 5/8 type X gypsum board to the bottom chord of the truss. The floor sheathing has to be minimum 1/2 inch thick wood structural panels, and that can be plywood or OSB as defined by the building code. It has to be glued in this case and attached with 8-penny nails at right angles to the truss or joist. Maximum spacing is 24 inches on center, and then the assembly gives the requirements for attaching each layer of the gypsum. The number of screws, the type of screw, the length of the screw, the on-center spacing. There's also, whereas the U.S. code only has really the one for trusses, the Canadian, their national building code, actually provides a very extensive list of prescriptive assemblies that include metal plate connected wood trusses in tables A 9.10, 3.1.B. And that can be a very good source for building designers who want additional information on prescriptive assemblies that have been tested for 1 hour. Canadians may use metric, but when it comes to the test and the 1 hour rated assembly is still a 1 hour rated assembly. So just something to keep in mind. Method 3, calculating the design. The IBC section 722.6 allows fire resistance calculations for wood assemblies. Basically, that's going to include the protective membrane, the framing members, other items that are going to be within that plenum, and then add those up and come up with a fire resistance rating for that assembly. Notice it does not include the unexposed membrane, such as the floor sheathing, is not included in the calculation. And again, looking in the building code, there are tables that list the maximum fire resistance rating that is allowed for the various products, and notice this calculated method is limited to fire endurance ratings of up to 1 hour. But in this case, we've got on this slide table 722.62, the time assigned to wallboard membranes, and if you notice, There's an additive method here where a half-inch gypsum wallboard is good for 15 minutes. If you combine two 1/2 inch gypsum wallboards, you are now good for 40 minutes. So it's not a 1 + 1 = 2. In this case, it's really a 1 + 1 = 3. Before I go on too, I want to make sure everybody's clear, and forgive me if I'm preaching to the choir, but the differences between gypsum type X and type C. Many times what you're going to find in these assembly tests is they'll specify, certainly when you get into the 2-hour assemblies, they're specifying a type C gypsum. The type X gypsum was developed back in the 1950s, and basically what that is, it's standard gypsum or calcium sulfate, but it's also typically has some type of glass fibers in it to help reduce the shrinkage of the gypsum as heat is applied to it. Calcium sulfate, the gypsum has about 50% chemically bound water in it, and so as you heat the gypsum, that water is boiled off, and as it boils off, the gypsum typically shrinks, and so if you're using it in a sealing application, the gypsum is going to shrink, opening up the cracks between the joints and allowing the flame and heat to get up into the assembly. So the type X with the fiber reinforcing helped stabilize that gypsum panel. And just tests on the gypsum itself, the literature I've seen, the type X basically is going to help increase the protection by about 4-fold in terms of if you were using, compared with if you were using just regular gypsum panels. Now the type C was developed in the 1960s, and that typically has the fiber reinforcing, and then they usually will add some other type of material that helps reduce the shrinkage, further reduce the shrinkage of the gypsum as you're applying heat, whether that's a vermiculite, which expands as you apply heat to it. But again, what they're trying to do is keep that panel as stable as possible. And so what's typically going to be found now is the type C gypsum is typically specified on most fire resistance rated floor sealing or roof sealing assemblies. Type X is commonly used in wall assemblies. If you have a copy of an older version of our document, you'll notice that it was, or if you go back to the older versions of UL or the Gypsum Association's fire resistance manual, a lot of times it was specified as proprietary type X, which was in parentheses meant type C, because the original developer of the type C, I believe it had to do with a kind of a patent, what they call that product, and so those that came to the game a little bit later had to come up with a different. But now pretty much everything is listed as type C for floor sealing or roof sealing assemblies. In our document, and if you look in the UL or the Gypsum Association documents, if they specify type X, they still mean type X. But now they'll say type C. You won't see proprietary or improved type X. It'll be just say type C. Method 4 is a comparison method, and the IBC allows the determination of fire resistance ratings based on a comparison of building element, component, or assembly designs having fire resistance ratings as determined by the test procedures set forth in ASTM E119 and UL 263. The combined with the provisions of IBC 104.11 listed in item 5 allow the building official to approve a design that complies with the intent of the provisions of this code, and that the material method of work offered is, for the purpose intended, at least the equivalent of that prescribed in the code in quality, strength, effectiveness, fire resistance, durability, and safety. Method 4 was basically used in developing the research report SRR number 1509-02, which is the calculated 2-hour fire endurance assembly. And here's a kind of a color of what that, or colored illustration of what this looks like. That assembly has a fire rating of 2 hours and a finish rating of more than 90 minutes. Now, finish rating is a term that's used to describe the protective membrane, which in this case would include these 3 layers of type 5/8" type C gypsum. And in order to get a 90-minute finish rating, those 3 layers acting together, they're thermocouples that are during the fire test that are installed at various locations in this, or along the assembly and within the assembly. And the finish rating typically is you're looking at 2 things: the any one thermocouple, the ambient temperature, or excuse me, the temperature at any one thermocouple located basically at the interface between that inner layer of, or the uppermost layer of the gypsum in this case, and the bottom of the truss cord. Any one thermocouple at that location cannot increase in temperature more than 325 degrees above its ambient temperature when the test started. So if it started at 70, it can't increase the temperature at any one thermocouple at that interface cannot increase by more than go up more than a temperature of 395 degrees. And then on average, all the thermocouples in that assembly at that interface can't increase more than 250 degrees above the ambient temperature. So again, if you're interested in the 2-hour calculated method, and there are 2-hour tested assemblies as well, but I would refer you, for the calculated assembly, I would refer you to the 1509-02 SRR report. The comparison method is based on Harmathy's 10 rules of fire endurance rating. We won't take the time to go through that during this presentation, but if you're interested in more information, I would suggest you consult sections 4-13 from the Society of the Fire Protection Engineers Handbook for more information. Method 5, like we said, is then alternate methods and materials that's allowed in the building code. And the highlighted and bold at the bottom of that paragraph, and I won't read it for you, but basically you can see that fire resistance is one, where alternate materials, design, and methods of construction are permitted. So the alternate materials and methods allows for other methods of developing a design by an approved source that complies with the intent of the code, and unless it can be demonstrated not to comply with the code, should be approved by the building official. And then, as I said before, in the latest and greatest version of the IBC, the 2015, assemblies are also allowed if they are approved or certified by an approved agency. So in conclusion, as far as fire-rated assemblies are concerned, the building designer must submit to a code jurisdiction a fire resistance rated design that incorporates incorporating metal plate connected wood trusses using any of the 6 methods allowed in section 703.3 of the IBC. If it's not a listed design, the building designer should submit details regarding how the submitted design was determined and show how it complies with the intent of the building code. For the truss manufacturers that are on this call, this is obviously outside the scope of what you're doing. Unless you're involved in design build, this is not something that you're going to get involved with. However, knowing this information, I think you can certainly help out your customers, certainly by helping them with the documents that SBCA offers, by having a copy of the this SRR 1509-01. When you get a set of construction documents and where it's specifying rated assemblies, Certainly if it's a tested assembly, you can then go and look and see, well, what's kind of the basics of that, and then make sure that your truss designs are going to meet the requirements in terms of the minimum depth and maximum on-center spacing and so on and so forth. And if not, you can obviously bring that to the attention of your customer and or the building designer. Some of the reference documents that are used in or cited in the report are listed here. We've talked earlier about the National Building Code of Canada, again, as a great source for many of the, or for several additional prescriptive assemblies involving metal plate connected wood trusses. And again, as I said earlier, if you end up going to the our website and download a copy of the report, the links in the report are hot. So in other words, every one of these that are underlined in red should take you to directly to that website or to that document.